ओके तो एक बार यूनिट 1 का एक बार रिवीजन कर लेते हैं। यूनिट 1 का नहीं, इसमें जो मेन पढ़ना था, जो क्वेश्चन आ चुका है। फंक्शन ऑफ एन ऑपरेटिंग सिस्टम, प्रोसेस मैनेजमेंट, मेमोरी मैनेजमेंट, सेकेंडरी स्टोरेज मैनेजमेंट, आईओ मैनेजमेंट, फाइल मैनेजमेंट, प्रोटेक्शन, नेटवर्किंग, कमांड इंटरप्रिटेशन। ओके, यूनिट 2 में है इंट्रोडक्शन, ऑब्जेक्टिव, कॉन्सेप्ट ऑफ प्रोसेस, सिस्टम सेल्स ऑफ प्रोसेस मैनेजमेंट, प्रोसेस शेड्यूलिंग वाला इंपॉर्टेंट है, शेड्यूलिंग एल्गोरिदम, ये सारा पढ़ेंगे। ओके, परफॉर्मेंस इवैल्यूएशन ऑफ शेड्यूलिंग एल्गोरिदम। ओके, what is process? What we learned before, we already learned that an operating system helps the computer run and manage resources like memory, CPU, files and devices. Now we will learn how the OS manages processes, one of the most important jobs of the OS. How OS manage processes, one of the most important jobs of the OS. What is process? A process is a program that is running. A program is just a set of instruction. When the program starts running, it becomes process. Example, when you write a C program and save it a file info.c, that's just a program. When you run it to display the f1.txt, it becomes process. Why are processes important? Your computer runs many things at the same time. Your game, file being downloaded, music playing, background, antivirus. Each one is separate process. What does a process what does a process need to do its job? A process needs CPU time to run, memory to load the program and data, files to read and save data, input output like keyboard or screen. Input output like keyboard and screen. All these are given by operating system when the process start. A process is not equal to a program. A program is like a recipe written on paper. A process is like someone cooking using the recipe. A program is like a recipe written on paper. A process is something cooking using that recipe. Two people can cook using the same recipe, but two processes can run from the same program, just like two processes can run from the same program. Types of processes, system processes or user processes. System may run the OS itself, like checking the printer and managing system. User program that you run, like game, browser, these can run at the same time. What the OS does with processes, the operating system is in charge of creating and deleting processes, start and stopping app and background tasks, pausing and resuming process, like putting a game on pause then playing it again. Process synchronization, making sure don't mess each other, the same memory deadlock handling, solving situation when two processes are stuck waiting for each other, deadlock handling. Understanding the concept of processes in simple explanation. What is processes? A process is just a program that is running. A program is a set of instructions saved in a file. सेम वही चीज़ है. A process is a program actually running and doing work. Example, you write a program to calculate marks. When you open it, run it, it become a process. Where did the term come from? The term process was first used by Multics operating system in 1960s. People define it in many ways. Program action tasks that run on something the CPU control and manage a unit of work handled by operating system. Two types of program: CPU bound program, IO bound program. CPU bound program uses CPU a lot. Example, complex math calculation. CPU bound program using CPU a lot. An IO bound program spends more time reading writing data. इनपुट एंड आउटपुट है तो फिर ये स्पेंड एंड टाइम होगा. ठीक है. वी ऑल्सो कॉल दिस CPU burst when a program is actively using the CPU, IO burst when a program is waiting for input output. Okay. Implicit and explicit are tasking made simple. When a program runs, the work when a program runs, the work is does can be split into tasks. These tasks can be managed in two ways. When a program runs, the work it does can split into two tasks. When a program runs, the work it does can be split into two tasks. These tasks can be managed in two ways. Implicit tasking system handle it. Okay. The operating system automatically treats each running program as a separate task called process. You don't need to manually define how to split the work into tasks. Common in general purpose systems like Windows or Linux. These tasks are usually temporary. They finish and disappear once the program is done. Example. You can open a calculator. OS treats it as a task. When you close it, the task ends. Explicit tasking, programmer defines it. The programmer manually defines multiple tasks inside the program used when high performance is needed. The program is split into multiple smaller tasks that can run in the same time. One main task called parent process can create and manage other tasks. Example, a video editing app may have one task loading video, another rendering, another is playing sound all at the same time. Why use explicit tasking? Speed. Different tasks can run at the same time. Better IO handling. Right, one task waits, then other keep working. User convenience. User can do many things at once. Multiprocessing. Different tasks can run in a different processor or computer in a network. Handling many users like a web server, giving each user their own task. What is tasking? When a program runs, it does many little jobs. Jobs means like calculations, loading data, printing result. These are little jobs are called tasks. Okay. These jobs are called tasks when a program runs. It does many little jobs. Jobs means calculation, loading data, printing result. These are jobs are called tasks. Two type of tasking, implicit and explicit. ठीक है, समझ में आ गया ये. थोड़ा सिंप्लीफाइड है और ज़्यादा अच्छे से. टेम्पररी आफ्टर द टास्क फिनिश. एक बार पढ़ लेते हैं इसको पूरा अच्छे से एक बार फिर से. Implicit tasking system does everything. Implicit system does everything. You don't need to do anything special. The operating system treats each running program as a separate task. Temporary after the task finishes, the OS removes it. Example, you open MS Word. OS runs it as a task. You close it, the task ends. You did not write any special code to split the job. The OS handle is automatically. Explicit tasking, you create a task inside a program. The programmer manually create multiple tasks inside one program. These tasks can run at the same time to make things faster or smoother. One task plays music, another task shows release, another task download. Process relationship in operating system. When multiple program called processes run at the same time, they have two kinds of relationship. process completes to get system resources like CPU time, memory, files, etc. Two apps are running at the same time, video player and browser, both the CPU to do their work. The operating system decides who gets what and when. The OS must share resources as fairly and safely. Cooperation. Okay, processes relationship in operating system competition. Cooperation. Some processes are designed to work together to complete a task. In a video call app, one processes handle the camera, one handle the microphone, and one send the internet. All these processes cooperate to make the video call smoothly. And two types of processes: independent processes or cooperating process. Independent process work alone, doesn't interact with any other process, safe and predictable, always give the same output if the input are same. Independent can be paused and resumed with no problem. Example, a calculator app doing one math calculation. Cooperating process share data, work together, process not predictable, output may change depending on the timing or order. If pause in the middle might not work right when resumed. Multiple parts of a chat app working together, sending, receiving, showing message. What is processes state? A process is just a program that currently running. As it runs, it can be different stage or states depending on what it doing. The five main processes state: new, the process is being created, the process is being created, it has not started running yet. Ready, the process is ready to run, just waiting for the CPU. Running, the process is actively using the CPU and executing instruction. Waiting and block, the process is paused, waiting some time like input or a file. Terminated, the process has finished running, it's done. New, when it's being created. Ready, the process is ready to run, just waiting for the CPU. And running, the process is actively using the CPU and executing instruction. Waiting, the process is paused, waiting for something. Terminated, the process has finished. Example, think of it like a student taking turn to speak in a classroom. Just the new student just entered the room, the student raised their hand and waiting for the teacher to call on them. Running, the student speaking, waiting, the student needs to book the continue but waiting for it. Terminated, the student finished speaking and sat down. Processes stage transition, how a processes move from one state to another state. The processes need something, so it stop and waits. Transition, running, ready, the OS says yes, you used. Transition, running and waiting. The process needs something, so it stop and wait. The OS says you are used enough time, let someone else have a turn. Ready, OS says now it's your turn. The process starts running, waiting. What the process saying has waiting for has what the process was waiting for has happened, it's ready to run again. Summary, a process moves between different states like ready, running and waiting. The operating system manages these states using a special component called scheduler. Okay, the operating system manages these states using a special component called scheduler. So process stage transaction: running, waiting, running, then ready, running से waiting, running then ready for running, waiting and ready. एक बार फिर से देख लेते हैं. ठीक है. What does implementing a process mean? To run and manage a process properly, the operating system needs to keep track of a lot of information about it. To run and manage a process properly, the operating system needs to keep track of a lot of information about it. What is the PCB? Process control block. The PCB, also called process table entry or switch frame, is like a report card or the file folder for each process. The OS store one PCB per processor. It helps the OS pause and process resume it later exactly where it left off. What is a context switch? Imagine your computer is like a kitchen and each process is like a dish being cooked. The CPU is like the chef who can only work on a one dish at a time. Now, if the chef is cooking dish A and gets a call from dish B, he must pause dish A, write down everything about dish A, recipe step, stove temperature, etc. This is the PCB of process A. Okay. Pick up the notes of dish B. Continue cooking dish B from where he left off. This switch between dish A and dish B called a context switch. How does a context switch work when switching between processes? The CPU saves the current state of process A. The CPU saves the current state of a process A into its PCB. It then loads the saved state of process B from its PCB. The CPU now continues work on process B. Examples, super easy. CPU is running process A and interpret occurs, something else need attention. The OS pause process A and save its state like freezing, then resume process B from where he had stopped earlier. Later it can come back and resume process A again. Why is context switch important? It allows multiple processes to share one CPU by taking turns, just like kids taking turns to play a video game. It allows multiple processes to share one CPU by taking turns, just like it's taking turns to play video game. What is process hierarchy? Think of a process like a person working on a task. In many systems, one person can create another process, like a parent having children. This creates a family tree or processes called a processes hierarchy. Think of a process like a person working on a task. In many systems, one process can create another processes, like parent having children. This creates a family tree of a process called a process hierarchy. Parent and child processes. When a process creates another, the creator is called the parent. When a process creates another, the creator is called parent, the new process is called the child. So, a parent processes can create many children, and those children can create a more processes grandchildren, forming a tree structure. What happened after creating? There are two main things to consider: execution style, resource style. The parent and children run together, concurrent execution, or parent waits until its children are done. Resource sharing: parent and children shares everything like memory or files, or child gets limited access or they don't share anything. Ending a child process: a parent process can stop, terminate its children process. Reason might be the children use too many resources, the child task is no longer needed. The parent can check on its children. For example, it can see if they are running, if they are still running. Unix. In Unix, the fork function system call creates a child process. The exit ends. Okay. Example from Unix: the fork system call create a child process and exit system call ends the process. After fork मतलब creates and exit मतलब ends. Both the parents and children continue to run. After fork, both the parents and children continue to run, but they can create more processing, forming a process tree. Okay, इसका छोड़ थ्रेड में आते हैं. What is thread? A thread is like a mini process inside a program. A thread is like mini processes inside a program. It often calls a lightweight process LWP. Thread is like a mini process inside a program. It's called a lightweight process. A process is like a whole worker. A thread is like a helper working inside the worker's task. Multiple threads can run at the same time inside a single program. Multithreading. If the task uses multiple thread, एक बार फिर से देख लेते हैं. A thread is like a mini process inside a program. It often calls a lightweight processor. A process is like a whole worker. A thread is like a helper working inside the worker's task. Okay, multi-threading. If a task uses multiple threads, we say it's multi-thread. Example, imagine a web browser. One thread loads the page, another thread plays a video, another thread listens to your click. In web browser, one thread loads the page, another thread plays a video, and next another thread listens to your clicks. All of these can run together as a thread in one single program. Thread versus processes. Feature. मेमोरी का बात अगर करें, each has its own memory, process has its own memory, shared memory among threads. Slower, faster, uses more resources, uses fewer resources. Communication needs special method, easy. Creation time takes more time, takes less time. Context switch over high and low. Why use threads? Faster than processes, share data easily, better performance for tasks that can run at the same time, use less memory of the CPU. Faster than processes, share data easily, better performance for tasks that can run at the same time, use less memory of CPU. Real-time computer in system with multiple processes, threads can truly run at the same time. Even with one CPU, threads take turn, giving it feeling parallelism. Summary. A thread is a part of process that can run independently. A thread is a part of process that can run independently. Threads are cheaper, faster and easier to manage than processes. A thread is a program share the same memory or files but have their own stack and register. Ideal for multitasking with a single application. Why use threads? Imagine you are doing homework while waiting for file to download. You are not wasting time, you are using it well. That's exactly the threads do in a program. Main reason to use threads: efficient use of CPU time. Even when one part of the program is waiting, another part can keep working. Programmers has control. The programmers can decide when and how threads should run. This helps write faster and smarter program. Faster switching, no kernel involved. Threads switch faster than process because they don't always need the operating system to help. Some CPU time better use. A program does not get more CPU time just because it has threads. It just uses that time more wisely. Level of thread. There are two types of threads: user level threads or kernel level threads. Managed by the program itself, fast and easy to switch between, but if one thread is blocked, the whole program may pause. Kernel level threads managed by operating system. Each threads run on a different CPU in multi-core systems. Slower to switch. Managed by operating system. It is managed by program. Fast and easy. Each threads can run in a different CPU. Slower to switch than user thread. Comparison कि मैनेज बाय प्रोग्राम, ऑपरेटिंग सिस्टम, यूज़र लेवल और कर्नल लेवल में. ठीक है. स्पीड में अगर बात करें तो वेरी फास्ट, स्लोअर, ब्लॉक कीपिंग मेक यूज इंटायर. हमने in simple words, threads make program faster and smarter. They help a program to do multiple things at once using the same CPU and efficiently. They are lighter, quicker and cheaper than the processor. What are system cells? System cells are now a program asking the operating system to do something. For example, reading a file, creating new process or terminating a process. System calls are how program asks the operating system to do something. When your program needs help from a OS. System calls for process management. System calls for process management. These are the system calls that manage processes. Create. What does it do? Start a new process. Think of it as giving birth to a new task. can define user or system level access, memory needed, priority, security info, delete या फिर terminate, exit. What it does, ends a process and remove it from memory, telling the OS I am done. Abort, when it does, forcibly kills a program. About why this process is misbehaving and stuff, used by the OS system. Fork या फिर join. Fork splits a process into two, both running at the same time. Join waits for two split parts of merge back together, common in Unix and Linux. Suspend block, pause a process, putting it in sleep mode. A process is waiting for something. Resume, wake up. What does it does? What it does, resume a suspend process. Delay puts a process into a sleep set amount of time. Get attributes, check the current status of a process. Change priority, change how important the process is. Example, सिस्टम सेल्स प्रोसेस मैनेजमेंट के अंदर ये सारा था. Copying a file. To read a file and copy it to another, the system cells may be used. Prompt user, write system cell, read file name, read system cell, open input file, open system cells, check if the file exists. Error handling system call, create output, create simple. Read from input and output, read write calls, both are close. Okay. Create, delete, abort, fork, join, suspend. Start a new process, end a process. Forcefully stop a process. Fork, create a child process. Join, waits the child to finish. Suspend, pause a process. Resume, resume a process. Delay, put a process to sleep temporarily. Get attribute, view process details. Change priority, adjust how urgently it runs. What is process scheduling now? Process scheduling. Process scheduling is how the operating system decide which program to run next on the CPU. Process scheduling is the operating system decide which process to run next on the CPU. It is like a fair and efficient queue of the CPU. It is very important in multi-programming, where many processes are in memory waiting for the CPU. Why do we need scheduling? The CPU is limited resources. Only one process can use it at a time. Single core CPU. We want to maximize CPU use and keep all part of the system networking efficiently. Without scheduling, process would have to wait too long or some might never run. Scheduling objective. Goals. They are the main goals of a good CPU scheduler. Objective. Maximize throughput, completes as many processes as possible in a short time. Improve response time, keep the system quick for user. Be predictable, jobs should take a consistent amount of time regardless of system loads. Minimize overhead, avoid wasting time switching between tasks too often. Balance resource use, use all part of the system fairly. Balance response and utilization, respond fast but also keep the system fully utilized. Avoid starvation makes your no process waits forever, everyone gets a turn. Enforce priorities, high priorities process should run before lower ones. Favor process holding key resources, help processes that are holding important resource finish faster. Degrade gracefully, if system is overloaded, slow down evenly, don't crash or freeze. Key terms: CPU utilization, keeping the CPU busy, work throughput, number of processes completed in a time period, response time, time taking to start, overhead, time wasted, management task, starvation when a process never gets the CPU. Process scheduling makes sure the CPU is shared smartly and fairly among all running processes. It is a core part of how an operating system works to make sure the system is fast, fair, and efficient. Type of schedulers: three kinds. Think of schedulers as a traffic controller for processes in system. They decided which process run when and for how long. Short term scheduler, CPU scheduler. लॉन्ग टर्म शेड्यूलर क्या है, मीडियम टर्म शेड्यूलर. शॉर्ट टर्म शेड्यूलर, लॉन्ग टर्म शेड्यूलर, मीडियम टर्म शेड्यूलर. What does it mean? Short term scheduler, what it does, picks which process run on the CPU next from the ready queue. How often it runs? Very frequently. Speed must be super fast. You are switching between 3 open apps. This scheduler picks which one gets CPU time right now. Long term scheduler, what it does, picks which processes are allowed into main memory from a long pool of jobs store or disk. How often it runs? Not very often. Purpose: control the number of processes in memory. Calls a degree of multiprogramming. Many modern systems don't even use a long-term scheduler. Medium-term scheduler, what it does, can pause a process from memory and resume it later. Why to free up medium? Can pause and process from a memory, resume. To free up space, improve performance, swapping. Scheduling criteria, what makes a good scheduler? CPU utilization, keep the CPU busy as much as possible so it completes more processes one time. Turnaround time, time for submission to complete. Waiting time, time spent waiting in a ready queue. Response time. Fairness, no process should be ignored or postponed forever. Priority respect, high priority process should get more attention. Conflict between goals, sometimes one goals can hurt another. Fast response time, maximizing through. In short, there are 3 types of scheduler: short term, long term, medium term. Decided who gets CPU now, decide who enters memory, can pause or resume process. Good scheduler keep the CPU busy, complete more job, give fair and fast service. Preemptive scheduling, interpretable. It means the CPU can stop a running process before it finishes and give the CPU to another process. CPU can stop running processes before it finishes. CPU can stop running processes before it finishes and give the CPU to another process. The paused process go back to the ready queue and waits for its next turn. Why use it? It helps important or urgent process run quickly. Useful in system where fast response is needed, like hospital monitor or self-driving car. Examples: round robin gives each process a fixed time slice then switch. Priority scheduling, high priority process interprets lower priority ones. राउंड रॉबिन प्रिमिटिव शेड्यूलिंग के अंदर में गिव ईच प्रोसेस अ फिक्स टाइम स्लाइस देन स्विचेस. और प्रायोरिटी शेड्यूलिंग, हायर प्रायोरिटी प्रोसेस इंटरप्रेट्स लोअर प्रायोरिटी वंस. SRTN, shortest remaining time next. If the one shorter job arrives, it interprets the current one. Shorter remaining time next. If a new shorter job arrives, it interprets the current one. ओके तो इसके अंदर पढ़े हम लोग राउंड रॉबिन, प्रायोरिटी शेड्यूलिंग, SRTN. नॉन प्रिमिटिव शेड्यूलिंग में व्हाट डज इट मीन? Once a process gets the CPU, it keeps it until it's completely done. Even if a smaller or more urgent task arrive, it has to wait. Why use it? Fair and simple. Good for batch system where predictable processing is more important than speed. Fair and simple helps important and urgent process. ये वाला तो examples FS, first come first served. Like a queue at a ticket counter. SJT, shortest job first, runs the job with the least processing time. But once it starts, it won't stop. First come first serve scheduling. What is it? It is the simplest scheduling algorithm. Okay, this is important. It is the simplest scheduling algorithm. The first process to enter the queue is the first one to get the CPU. The first process to enter the queue is the first one to get the CPU. Think of it like a line at a ticket counter. Whoever come first gets served first. How it works? The OS use a queue to manage processors. It picks the processor at the front of the queue and lets it finish moving to the next one. It is a non-primitive algorithm. Process run until it finished. Advantages: simple to understand and implement, fair in the order of arrival, no process jumps ahead unfairly. Disadvantages: long waiting times for small and quick jobs stuck behind longer ones. Can cause the convoy effect. One big process slows down everything behind it. Bad for responsiveness in real time or interactive system. Okay, shortest job scheduling. What is it? The CPU is given the process that need the least amount of time to finish. It always picks the shortest job from the queue to run next. It is a non-preemptive algorithm. How does it work? Looks to the burst time of all waiting process. अच्छा उसका definition नहीं लिखा है पूरे अच्छे से. Round robin scheduling, what it is? It's a primitive CPU scheduling algorithm. Each process gets a fixed amount of time called a time quantum and time slice. After the time it up, the CPU moves the next processes in the queue. How it works? All processes are stored in a queue. The first process gets the CPU for a short time. It finishes in the time, great. If not, it goes to the back of the queue. The next process is given the CPU and the cycle repeats. SRTN. What is it? It's a primitive version of shorter job. Primitive version of SJT. At any time, the process with the least remaining CPU is given the CPU. If a new process arrives with less time left than the currently running processes, interpret the current one. How does it work? The CPU checks the remaining time of a process in a ready queue. It sends the process with the shortest time. If a new process comes in less, the process that was interpreted will wait and continue. Later, it becomes the shortest again. Priority scheduling. What is it? Every process is given a priority number. The CPU is given to the process with the highest priority. If two processes have the same priority, they are scheduled first come first serve. Priority scheduling. Every process is given a priority number. The CPU is given to the process with the highest priority. If two processes have the same priority, they are scheduled first come first serve. How does it work? All processes are in a ready queue. The scheduler picks the one with the highest priority. The process runs until it finished. Problem: identify blocking and starvation. A low priority process may never get a chance to run because higher priority process keep coming. This is called starvation. Aging. Aging is a technique that slowly increases in priority of waiting process. So a low priority process that waits long enough will eventually have high in, uh, a long priority process that waits long enough will eventually have high enough priority to get the CPU. Fast response an important task. With aging, it prevents starvation. Okay, done this. Next unit 3 in next live session.